Alrighty, welcome back, boys and girls. It's your man, Math Man, Mr. Shank, coming to you live from Summit Academy. In this video, we're working on unit number 7, lesson 10. We're now moving into those scientific notation now. So we'll talk about exponents, but for today, we're going to be able to plot multiple powers of 10 on a number line. So it says, first part, it says to label the tick marks on a number line. So each of those little dash marks that you see on a number line are the tick marks. And so what we can say is labeled like that, is we start at 0 and we end at 10 to the 7th power. And so what we can do is this. I can actually say I can have 1 times 10 to the 6th power, 2 times 10 to the 6th power, 3 times 10 to the 6th power, 4 times 10 to the 6th power. So it's going to be a lot of this where we are labeling each of the tick marks one piece at a time because they are evenly spaced out on that number line. And if you notice, each of those has the same exponent, but we're just increasing it by that coefficient, meaning that value in front. So we have 8 times 10 to the 6th power and 9 times 10 to the 6th power. And then instead of 10 times 10 to the 6th power, we can combine those exponents because we would say this is going to be 10 times 10 to the 6th power, which we would be saying, 1 plus 6 is the same as the power 7. So now using those same things, the same tick marks, we're going to have that exponent. So I'm going to mark these in here like this. So I'm going to do 1 times 10 to the 6th power, so on and so forth. So now once you have those in there, it says place the numbers on the number line. So we have a couple of values that we can change around here. And what we can actually do is we can say, hey, this is going to be equal to, we can say this is going to be equal to, let's say, 4 times 10. And if we need the exponent, we can count these zeros. We're going to say 1, 2, 3, 4, 5, 6, 0. So we're saying plot the point 4 times 10 to the 6th power, which is going to be this point here, and we can label it A. Then for the next one, we're doing B, but one is already in there, so we don't have to calculate it, so it's going to be B. Then for C, we can say that's going to be the same as this. So that's going to be halfway in between 0 and 1 times 10 to the 6th power. So that's going to be C down here. Then for D, we can move that decimal one step to the right. So this is going to be equal to, and say this is the same as 7.5 times 10 to the, try that again, times 10 to the 6th power, which is in between 7 and 8. So that's going to be D right there. And then lastly, we have E. Similar to what we had before, we can move it one step to the right, so we can move it one step to the right, so that way our exponent is 6. So this is going to be equal to 6 times 10 to the power 6 again. So we're going to say it's going to be on that point right there. We label that as E. Then for number 2, it says, which is larger? It says, is that 4 million or 75 times 10 to the 5th power? So what we can say is, again, make sure you remember, we're saying this is the same as 4 times 10 to the 6th power, and the 7.5, which is in green, we're going to say that's going to be 7.5 times 10 to the 6th power. So we can compare the leading value because that is the only difference between these two, where we have the times 10 to the 6th power is the same in both of them. So we're going to say that let me circle that for us. We're going to say the 75 times 10 to the 5th power is going to be the larger one, and it's going to be twice as large. And we can figure that out by looking at that number line and the length from 0. So if we look from 0 to that point A, right here, it's almost half as long as it is to that point D, which is going to be that point for the value 7.5 times 10 to the 6th power. Moving on to the next part, it says the table shows how fast light waves or electricity can travel through a different material. And so what we can do is this. I can label those materials with different letters. So I'll say space is A, water is B, copper is C, diamond is D, ice is E, and olive oil is F. So we're trying to figure out, okay, how can we rewrite some of these so that way it's a little bit easier to look at. Because what we have to do is we have to place these on a number line. So I'm going to say this is going to be 3 times 10 to the 8th power. This is going to be equal to exactly what it has, so we don't need to change that one. However, for the third one, we can have 2.8 times 10 to the 8th power. We can move this 2 times to the right, or sorry, 2 times to the left, so that way we have that exponent as 8. So it's 1.24 times 10 to the 8th power. And this one's good. And the last one, we can say this is going to be 2 times 10 to the 8th power. All right, so it says, which is faster, light through the diamond or light through ice? How can you tell from the expressions from speed? For speed, I should say. So we're looking at D and E for this one. And we can say, well, if I look at the two options, since both of them are times 10 to the 8th power, I can say, okay, which one's larger, 1.24 or 2.3? Well, we're going to say for this one, the light is going to be faster through ice compared to the diamond, because say 2.3 is greater than 1.24, which is what we have here. All right, so what I'm going to actually do is I'm going to take a screenshot of this real quick so that way we can remember our values that we have. So give me 1 second. Copy, and then I'm going to paste this in so that way you can use it. Okay, so now on this side, we're going to say, move this down here for now, I guess. It says, let's zoom in to highlight the values between 2 times 10 to the 8th power and 3 times 8. So in between these two dash marks is where we're looking, and now they expanded out, and now we can label these as follows. So what you can do is like this. You can either write it horizontally or you can write it vertically. Either way works. So once you have those tick marks labeled, again, you can write them vertically like this, where they, they're going a little bit sideways, or you can, write them how you normally would write. Either way works. But you want to make sure that you label those first. And so we labeled our tick marks, so that one's done. And now we can say, okay, when you are looking at number 3, it says plot a point for each speed on both number lines and label with the corresponding material. So what you can do is we can just use those letters A through F, and we're going to place them on this number line. So what I'm going to do is I'm going to do different colors for these. So I'm going to say for here, let's actually do red. That one stands out a little bit more, or maybe blue. Let's do blue. Okay. So for A, we're on 3.3 times 10 to the 8th power, which is going to be up here. So we're going to say plot the point up there, label that A, and then that's going to also be down here, which is labeled as A. Then we can say for B, that's going to be 2.25, so just slightly to the right of that 2.2, so we can say that's going to be, or actually it's going to be halfway in between since it's 2.25. So we'll say it's going to be B. Label that about right there. Label that B. For C, it's 2.8 times 10 to the 8th power, so that's going to be down here. Label that C. So put that on the smaller line, but tougher to do, but that's why they have the zoomed in one on the bottom. And for D, that one's not on that line, but what we can do is we can put it just slightly up here, so we're going to put it on the smaller zoomed out number line. And then for E, it has 2.3, so that's going to be right here. It's going to be E, and that point F is going to be on 2.0, so it's going to be right there. So let me put those two in here. So that was E, and that starting value was F. Okay, so make sure that you're working with that zoomed in number line, so that way it's easier to see. So let me now get rid of this one. We're saying, okay, there's one speed that you cannot plot on the bottom number line. What is it? And we can plot it on the top line. So we're going to say that diamond cannot be plotted on the zoomed in line because it is less than 2 times 10 to the 8th power. And then it says, for number 5, which is faster, light through ice or light through diamond? How can you tell using that number line? So we're saying for that number line, we're going to say that using that number line, it says light through ice is faster because it's further on the right on that number line. And I believe D and E was what we were looking for. So we're saying D is diamond, so look how it's, the whole way back here, and E was ice, which is further than that. So just comparing on the number line, we can see that E is going to be faster than D. All right, moving to the back of that first page. Now it says to find 3 different ways to write the number 437 using the powers of 10. So what we can do is we can write it like this. We can say, again, each of these are going to be different values. So if I was to have my decimal place here, I can say, okay, I have 1, 2, 3, 4, 5 decimal places I'm moving it. So I can have 4.37 times 10 to the exponent of 5. And then if I decrease that 1 each time, so I can move that decimal, so I can say 43.7 times 10 to the 4th power, and I can also say 437 times 10 to the 3rd power. So notice how the exponents are decreasing each time. Okay, then it says for each number pair of numbers below, circle the number that is greater, and then estimate how many times greater. So we're going to say, for this one, again, notice how both of them have 10 to the 8th power. So we're going to say that actually the one that is larger is going to be the 17. And we can say it's going to be about, or actually over, it's going to be over 4 times as large as the 4 times 10 to the 8th power. Then for the next one, we're going to say same thing. It has the same exponent, so we're going to say this one is the one that we want to choose. And that's going to be almost 4 times larger. And then lastly, we're going to say for this one, we have 42 times 10 to the 7th power, which is the same as 4.2 times 10 to the 8th power. And so that they have 10 times, or 10 to the 8th power on both of them, we're going to say that this one is going to be actually that one on the right, because that first value is larger. We're going to say just about 2 times larger. Then for number 3, it says what number is represented by this point. So make sure you can label these numbers first. So label these tick marks, which I'll do here in a second. All right, so now that I have these numbered, again, take your time as you're writing these down. You can notice how it ends at 10 to the 12th power, and so we're going to say that each of these is going to be 1 times 10 to the 11th power. So each of these exponents is the 11th power, and then on a zoomed in line, we're actually saying it's going to be. So for that, now that you have your bottom line, it's going to be counting by 7.0, 7.1, 7.2, all still times 10 to the 11th power. And so what we're trying to figure out is what is the point represented by A? Well, we're going to say that that is going to be this point right here. And so since we have it labeled, we're going to say A equals 7.4 times 10 to the 11th power. Make sure you have those other points labeled so that way you know how we got that answer. Then for the next one, it says here is the graph of days and the predicted number of hours of sunlight H on the D fifth day of the year. So we're going to say for part A, it says, is hours of sunlight a function of days of the year? And how do you know? So we're going to say H is a function of D. And it says for every D, there is only, or sorry, there's one, I should say, there's one and only one value of h. So as long as there's only one value of h, again, on our horizontal axis it was days, on our y-axis it was hours of sunlight, and so we're able to kind of compare. Again, this is our y value, or our y-axis, and this is normally our x-axis. So it's always going to have that x-axis, or that x is going to be the independent variable, which means our dependent variable is a function of our independent variable. Then for part B, it says for what days of the year is the number of hours of sunlight increasing. So if we look at our graph, notice how it kind of changes at this point here. What I can do is I can actually label that. That's going to be 180, 18. And so we're going to say, it's increasing. So let's say from 0 to 180, it is increasing. And from 180 to 365, it is decreasing. So you have to make sure you're saying as you're going up through this graph, it's increasing, and then once you get to that point, it actually goes down. And then for the last one, it says which day of the year has the greatest number of hours. Well, we're talking about this point that we already pointed out. So we're going to say at that last one, it says day 180 has 18 hours of sunlight. All right. And then for the X ticket, it looks something like this. It says we described numbers in this lesson using both powers of 10 and using standard decimal value. For example, the speed of light through ice can be written as a multiple power of 10, such as 2.3 times 10 to the power 8 meters per second, or as a value such as 230 million meters per second. Use the number line to answer the questions about points A and D. So what you're going to have to do is this. You're going to first have to move so let me actually move this around a little bit. And let me make that larger. You're going to have to, so first, let's say first label tick marks, let's say marks on both number lines. So once you label those, then you'll be able to have those points. So let's actually do that first. So now that you have those points labeled, again, you can use those different points to be able to come up with different values. So make sure you can answer those questions that go with the points here. So it says for number 1, describe point B as a multiple power of 10 and as a full value. So for example, I could say for this one, I would say for that point B, it's going to be 2 times 10 to the power 8, which if I multiply it out, I just count those zeros. So count zeros. So I'm going to say I have 2, I have 1, 2, 3, 4, 5, 6, 7, 8. So then I can actually use those commas every 3 spaces to make my number. So try that one out, come up with another value that is in between A and B. Make sure you label it as power of 10 and as a full expanded value. Be sure to ask questions as they come up, and as always, super slam that subscribe button.